Continuing with this theme of Facebook meets finance, I'm going to apply this to portfolio theory, and more specifically, I'm going to look at what I call naive diversification and specific risk. I'm sure these four people, Charlotte, Carrie, Samantha and Miranda, are on your Facebook page, not forgetting also Mr. Big. What you will see is that I'm going to make all of your friends equally worthy as well as being equally risky. I'm going to assume you like a set of friends who over time give you a high average return, but you prefer their collective mood swings to be mild rather than extreme. So other things being equal, you prefer a portfolio of friends who taken together are low risk rather than high risk. The kind of questions we're going to answer is, why do you go out with groups of friends rather than just one? How do we measure the risk of each friend? What determines the risk of your overall night out with many or your portfolio of friends? And then to draw out some implications for investments in stocks. Well, risk is volatility in behaviour. It's any variation around your average behaviour. We classify an individual's behaviour into two sources of risk. One is called specific risk, and not surprisingly, this is specific to particular individuals. So someone might have a good or a bad day at the office, might find a $100 bill, or might have lost a $100 bill. This type of risk, specific risk, as we'll see, is independent over time and unrelated to other people's behaviour. There is a second kind of risk, and this risk affects everyone at the same time to a greater or lesser extent. And this is caused by recessions, booms, unemployment, inflation, these kind of macroeconomic variables. Of course, each of these things affects everyone to some extent, but clearly it tends to affect poor people more than rich people. Okay, here's your new friend, and what we're going to do is to measure the riskiness of this friend. And we're just going to consider one friend, let's call him Brad. He's volatile. Sometimes when he goes out, he's very happy 50% of the time. Maybe he's won an Oscar that night. And in which case, if you go out with him, you give him a score of plus 30. On the other hand, you may go out with him, and in this case, he's not very happy, and you give him a score of minus 10. These two outcomes occur with equal frequency. And so, the mean score you give him, if you go out with him over several nights, is just the average of plus 30 and minus 10. So his mean score is 10. In fact, on any particular night, he never actually gets the mean score of 10. He gets either plus 30 or minus 10, which means that the volatility in his behavior we measure as 20. A score of 20 is his variability or volatility in his nightly behavior. So if you go out with Brad for 100 nights, you'll score him each night as either plus 30 or minus 10, and these scores are completely random. So the riskiness of going out with Brad is 20 points per night. Now we want to move on where you just don't go out with Brad every night for 100 nights. That's fairly risky, but what you're going to do is to go out 100 nights with a portfolio of 10 people randomly chosen from your Facebook page, and you're going to spend 1/10 of the total time per night with each person. This is known as an equally weighted portfolio. And you're going to go out with identical people to Brad. That is to say, they're all equally risky. They can all score either plus 30 or -10. They have the same volatility and the same mean score. For any one of these people, their behavior is random over time. So for example, if you just go out with Brad and on a Monday you give him a score of +30, you have no idea whether you will be giving him a score of +30 or -10 on Tuesday. His behavior is independent over time. Now let's consider another example of independence. And this is independence not over time, but across people. What this means is, if Brad gets a score of +30 in the first half hour of a Monday night, this is of no use in predicting what Beyonce's score will be in the next half hour. There's an equal chance that her score will be either +30 or -10. But you don't know what Beyonce's score will be at the point at which you kiss Brad goodbye. Obviously, this assumption rules out Brad and Beyonce living together, so that their specific risk or their specific behaviours are independent of each other. Well, here are some possible random outcomes from your speed dating based on a random collection of people from Facebook pages. On night 1, you can see the score for each of the 10 people, and it so happens that the nightly portfolio average score is 10 exactly. This would be rather unusual. On the second night, Tuesday, that you go out with the 10 random people, you can see the scores, and these average to 14. Now on night 5, it's a really good night. You give everyone a score of +30, making a mean score for the night, for your portfolio of 10 friends, of 30. Now it may look as if the outcome on night 5 is not random, but when something is random, you can very often, on some occasions, get what looks like to be a predictable pattern. And this is the case for night 5. Okay, let's have a look at night 98, where everybody gets a score of -10. They're all rather sad, giving a mean score on the right hand side of -10. Again, this won't happen very much on any particular night, but it will happen on some of the 100 nights. Now, looking at the column nightly portfolio average score, you can see that on each night the portfolio score is not exactly 10. It does vary, although if you look down that column and take the average of all of those numbers, it will come out to be very, very close to 10. And here it's 10.001. The final column on the right hand side is called surprise, and all that is the difference between the nightly score and the overall mean of 10. On night 5, everyone got a score of +30, so the actual score for your portfolio was +30, but that is 20 above the mean score of 10, so you were rather surprised that night, obviously positively surprised, and your positive surprise for your portfolio was +20 points. Night 98, everybody's sad, and the mean score that night was -10, which is actually 20 below the mean of +10. So the surprise there was -20. And the variability of your portfolio scores is actually around 6.3. Let's summarize what's in this diagram. If you go out just with Brad every night for 100 nights, you have a mean or average score of 10 over the 100 nights. But the outcomes on any one night are extremely volatile, either +30 or -10, which gives a volatility or variability in Brad's score of 20. On the other hand, if you randomly choose from your Facebook page 10 people and you spend half an hour with each one, then the portfolio score that you give them each night is much less variable. It's the same mean score of 10 as you gave to Brad, but the variability in the score is much lower. So they have the same mean score, but if you go out with 10 people rather than with just Brad, you have less volatility in the score, and you like less volatility. That's our assumption, at least. So the moral of these two graphs are, you should dump Brad. So portfolio theory, like friendship, is about risk and return. You like a high average score or a high average return, but you don't like volatility in that score, you don't like risk. You can reduce specific risk by naive diversification. Simply spend an equal amount of time with 10 friends. If you want to look at more of this type of material, you could look at the book Investments by Cuthbertson and Nietzsche. Thank you. Goodbye.